Hello, Assalamu alaikum. I'm Mohammad Tawadur Rahman, ID 192352821. Today my topic is single round uh, of DES code implementation. DES or data encryption standard has been found vulnerable against very powerful attacks, and therefore the popularity of DES has been found slightly on the decline. DES is a block cipher and encrypts data in blocks of 64 bits each, which means 64 bits of plain text goes as the input to the DES, and uh, which produce 64 bits of ciphertext. The same algorithm and key are used for encryption and decryption with minor differences. The key length is 56 bit. The basic idea is shown in the code. We have mentioned that DEs use a 56-bit key. Actually, the initial key consists of 64 bits. However, before the DES process when it starts, every 8th bit of the key is discarded to produce a 56-bit key. That is, bit positions 8, 16, 24, 32, 40, 48, 56, and 64 are discarded. Thus, discarding of every 8th bit of the key produced 56-bit key from the original 64-bit key. DES is based on two fundamental attributes of cryptography: substitution, also called fusion, and transposition, also called diffusion. DES consists of 16 steps, which each of which is called a round. Each round performs the step of substitution and transposition. Let us now discuss the broad level steps in DES. In first step, the 64 plain text block is handed over to an initial permutation function. The initial permutation is performed on plain text. Next, the initial permutation processes uh, performed on the initial permutation is performed on plain text. Next, the initial permutation produces two halves of the permuted blocks, says left plain text and right plain text. Now, each LPT and RPT go through 16 rounds of encryption process. In the end, LPT and RPT are rejoined and final permutation is performed on the combined block. The result of this process produces 64-bit ciphertext. The initial permutation, as we have noticed, the initial permutation happens only once and it happens before the first round. It suggests how the transportation in IP should proceed as shown in the code. For example, it says that the IP replaces the first bit of the original plaintext block with the 58th bit of the original plaintext, the second bit with the 50th bit of the original plaintext block, and so on. This is nothing but jugglery of the bit of positions and the original plaintext block. The same rule applies to all of the other positions shown in the code. As we have noted, after IP is done, the resulting 64-bit permutated text block is divided into two half blocks. Each half block contains 32 bits and each block of 16 rounds. In turn, consists of the board level of step outlined in the figure. We have noted initial 64-bit key is transformed into a 56-bit key by discarding every 8 bit of the initial key. Thus, for each a 56-bit key is available from the 56-bit key, a different 48-bit subkey is generated during each round using a process called key transformation. For this, the 56-bit key is divided into two halves, each of 28 bits. These halves are circularly shifted one by one two positions. Depending on the round, for example, if the round number 1, 2, and 9 or 16, the shift is done by one position. For the other rounds, the circular shift is done by two positions. The number of key bits shifted per round is shown in the code. After an appropriate shift, 48 of the C56 bits are selected. For selecting 48 of the C56 bits, the table is shown in the figure and given below. The instance after the shift, bit number 14 moves on the first position, bit number 17 moves on the second position, and so on. The observe of the table carefully. Because that initial permutation we had two 32 plain text areas called left plain text and right plain text. During the expansion permutation, the RPT is extended from 32 bits to 48 bits and permuted as well, hence called expansion permutation. This call happened. The 32-bit RPT is divided into 8 blocks. Each block consists of 4 bits. Then each 4 blocks of previous step is then expanded to a corresponding 6-bit blocks. This process results in expansion as well as permutation of the input bit while creating output. The transposition process compresses the 56-bit key to 48 bits, and then the expansion permutation process expands the 32-bit RPT to 48 bits. Now the 48-bit key is XOR with 48 RPT, and the resulting output is given in the next step.